Hello, and welcome to Containers from the Couch. Thank you, everybody, for joining us today. This is a really exciting show. I always love when we're able to have a show where it's not just me talking. It's not me or Justin, but it's someone that has such incredible insight that's outside of what Justin and I and Nathan do day to day. And we're really fortunate to have Vlad on the show today, who's going to walk through the amazing work he did, which I'm sure you've seen. If you haven't seen it, I'm not sure where you are, but we will share the link just to make sure so you can see his blog on scaling containers on AWS in 2022. So before we get into it, let's just start with, Vlad, why don't you just say hello, tell us who you are, and then we'll go from there.
Awesome. So, hey, everybody, I'm Vlad Ionescu. I am an AWS container hero, which means that I do not work for AWS, so I can be mean to AWS services. Don't worry. Anyway, so yeah, what do? I like to joke that I'm a professional mistake avoider, which is a nicer way of saying independent consultant. I focus a lot on helping companies get to high-performing levels as per the DORA definition. And that means, besides many other things, also working a lot with containers, serverless, with AWS, and a bunch of services. I also work with a bunch of SaaS companies and a lot of companies that need to scale a lot. So I have a series of blog posts that now had its third installment, Scaling Containers on AWS in 2022, which is what we're here to talk about.
Yes. And, I just want to say, and then we'll do quick introductions. I feel like people know us, but we'll do that really quick. But Vlad, you have such a unique perspective because you're out there consulting with customers. You are seeing customers using ECS, EKS, Kubernetes, Lambda. You really get to see across the wide spectrum of services and have some really good perspective there. So I think when you take that and then you mix it in with performance testing and just trying to really go through the nitty gritty, it's really a recipe for an awesome story here. So let's just really quick. I'm Adam. I'm a developer advocate on the container services team. Justin, why don't you go ahead?
Well, you just did it. I'm Justin also. I'm a developer advocate on the container services team. I deal a lot with Kubernetes and Carpenter. It's been my focus in the last year or so.
And I'm Nathan. I'm a developer advocate on the team. I've been working with ECS for a long time and always excited to work on ECS performance.
Awesome. So why don't we just let's get right into the blog, and let's just talk about, first of all, Vlad, why don't you just take us through, what motivated you to say, I want to write a blog on scaling containers.
Wait, I thought we were going to read this word for word. It's a 45-minute.
You know what? Actually, let's do it the Amazon way. We're going to take 30 minutes. Everyone read, and then we'll discuss. I'm kidding. That was a good one, Justin. So Vlad, tell us,
it's not a joke. Before I get into my movie, it's not a joke. It really does take 45 minutes, and that's the official estimation from a bunch of software. For some folks, it's maybe closer to half an hour, but for the majority of people, it's gonna be 45 minutes or more. So, get a glass of water, get a cup of tea, some whiskey if you're doing Kubernetes. You're gonna need some time to read it.
I'm a slow reader. I spent about an hour and a half with it last night, so...
But
it is also really concentrated.
And there's a lot to take in here. And I think if you don't feel like reading and spending 45 minutes reading, you can spend 45 minutes listening to us talk through it and go through the highlights. So,
yep. I guess the first question I have is which services did you put in this blog post? And how did you pick the particular variations that you chose for discussing in this blog post?
Yeah. Let's first start with Adam's question. What motivated me to do this? Why? Do I just have bounds of free time to start testing this? No. So back in 2020, when I ran my first test, I only tested EKS on EC2. So that is Kubernetes with EC2 workers versus EKS on Fargate. So still Kubernetes, but with serverless workers with Fargate. And ECS on Fargate, which is ECS, another container orchestrator, Amazon one, with Yes, this is the blog with, so they were all of them. And we also have tuned Fargate there, which is Fargate with some increased limits. And this was the first time I tested it because I had a customer. I'm not just doing this for the kicks. I'm doing this because there is a need for this type of scaling. And we were doing Kubernetes at high scale. And it wasn't only the fact that we were doing high scale, we were having very, very spiky workloads. For anybody out there that's doing SaaS or that's trying to optimize cost, you know that you can get a request in, you need a bunch of resources to process it, and then ideally you want to scale down so you don't just throw money out the window. And that's the big advantage of the cloud. Like, it's not a data center you prepay for 3 years of servers, whether you use them or not. So being able to scale up and down to meet demand, to actually only respond to requests, was a big draw. And for my customers, we were really, really spiky. So we were scaling to, I think it was about 2,000 C5 4x larges or 6 C4 4x larges. Anyway, it was quite a lot. And that also came with a delay. Fargate didn't came with a delay. And Fargate being serverless was much, much easier. We didn't have to stress about OS updates. We didn't have to stress about patching the Linux kernel. We didn't have to stress about patching the container runtime, sudo, whatever. Like, that wouldn't have been our concern anymore. AWS would handle that, which was a really, really big draw. So I tested it. And the results were great, but not ideal. As we can see here, in 2020, yeah, so things change a lot. In 2020, Fargate took about an hour to go from 1 container to 3,500 containers, which wasn't ideal, especially when you compared it with Kubernetes, which took about 10 minutes, less than 10 minutes. But it was an awesome fit even then, and I started moving services with my clients to Fargate, but not the intense scaling ones. Fargate was fast enough for some things, but not for all the things. That changed though. Later that year, I got a reInvent talk. And at that reInvent talk, I presented what we can expect from AWS containers in 2021. So containers obviously move fast. AWS moves even faster. So the whole landscape changes a lot. We have to stay up to date. And Adam, if you can open up the YouTube video, you don't have to. But what we saw in 2021 was that things started moving even faster. Fargate went from my gorgeous face there. Fargate went from about the 1 hour mark in 2020 to, I think it was 15 minutes in 2021, which was a dramatic improvement. It enabled so many more things. It enabled folks to stop stressing. And I also extended a bit. So I wasn't only doing that, I was also comparing, what did I add here? ECS on EC2. I added that to the suite. So this was awesome. This was fine. It enabled me and my customers to move even more workloads to using Fargate because, okay, we know how fast they're scaling. We know how they're behaving. Fargate has evolved enough to actually satisfy our constraints. And that was absolutely awesome. And that's going to be a trend, how things evolve. And now we're in 2022. So, of course, I had to do an update. This is still for my customers. So we needed to see. And when somebody says, yeah, we want to use service X because it scales better. Okay, that's very abstract. Show me how much better it is. Tell me, because if you want a company to spend a bunch of man hours, a bunch of effort into maintaining, I don't know, a Kubernetes cluster running on EC2s, that needs to be justified. That needs to make sense for the company because it's a big money investment no matter what people say on the internet. It costs a lot. And yeah, we now have this data, and hopefully I'm also sharing this publicly because nobody should run these tests. Like, I've ran them once, I spent $7,000 on it in AWS credits. I destroyed the planet. The carbon emissions are still to be determined in the AWS carbon cost calculator thingy. I don't know the full name. So please use this. Don't necessarily retest. Retest it with your workload.
So,
But that's the short history of it.
and just the one thing I want to just point out here is, on this 2020 graph, just to see the difference of where Fargate was, right? 60 minutes, you said, to get to 3,500 containers, to less than or I don't know, maybe 6 minutes to get to 3,500 roughly, right? That's a huge performance increase. And the best part is, and you mentioned this in the blog in a couple places, the user of Fargate didn't have to do anything to reap these benefits. That's huge, right?
I agree. Like I say this in the blog. Like if you build, I have customers that I was working with. Again, I focus a lot on getting companies to be high performing. That means not wasting effort. We had applications that we moved to ECS on Fargate in 2020. The scaling speed was enough for us. The pricing was fine. We were happy with it. We started moving that. We didn't have to change one thing about that application, and we got dramatic speed improvements without having to do anything, without having to stress about anything. It just happened. And I don't think people fully understand how big of a deal that is. Like, we just got that. We didn't have to do anything. We just focused on bringing business value. And that's in my view, the biggest benefit of serverless and of offloading effort to AWS. Like if you're just using AWS because, we're using VMs and S3, like, yeah, it's an improvement over the server in your basement and the hard drives that you have to manage and maybe die. I'm not gonna deny that, but you're not taking full advantage of that. AWS has, I don't know how many engineers that spend their whole time on improving these things. And that has been extremely visible for any customer of ECS on Fargate. Again, doing nothing, going from 1 hour to less than 5 minutes. That's changing companies. It's not just, we're scaling faster, it's fine. No, it's fully changing companies. It's changing how applications run. It's changing how fast things are being processed. Imagine, I don't know, using a service and it takes an hour and then it takes 5 minutes and you're like, awesome, they did some work, they really stressed to improve our experience. Yeah, no, they were just using ECS on Fargate. Ta-da!
Yeah, when you talk about changing businesses, one of the biggest changes that I've seen is more and more of the larger companies and larger deployments, they're moving more to a model with continuous integration and continuous deployment, where they want their developers to be able to deploy the service not just once a week, or once a day, but many times per day if they want to. And when you're in a situation where you have thousands of containers and it takes an hour to deploy, that's a little bit of a bottleneck there. And it also makes these deployments scary, because what if you roll out a change that's bad and it causes a bug, and now you're going to have to do another rollout for an hour. So there's this mental barrier where you say, I'm going to slow down my rate of development. I'm going to be extra careful because I'm afraid that my super long deployment is going to cause an issue. It's going to take a long time to roll back, versus you're talking about a 6-minute deploy. That's a different story. Maybe I roll something out, there's a bug. It's not the end of the world. I can roll out a fix in 6 minutes, right?
Yeah, and that's it. They're not just like vanity metrics, like, oh my god, we're rewriting it in Rust. It's not that. It's direct impact. If I love Rust, don't get me wrong, but if it takes your company an hour to fix a bug because you're deploying slowly, or you have, change management meetings that have to happen before every single deploy, what are your customers going to choose? Your company or the other company where a bug is automatically reverted in less than a second because they're doing feature flags? It starts being a really big draw, and this has direct business impact.
I mean, the 60-minute to 6-minute is essentially a 9, right? Like a percentage, like you're getting an actual order of magnitude faster. So if this is happening often, like Nate said, like if you have an outage and it takes you an hour to recover versus 6 minutes, like that is for the month, 4 nines or 3 nines. And so that's a huge deal of just like how much you can guarantee for your customers, what your downtime would be, how fast you can recover. All that stuff matters hugely for a lot of people.
Oh, there is a comment in here that is so good. I'm going to just flash that up. When the bottleneck becomes the process and not the technical complexity, it's a huge win, right? So the gates are open, that you're not limited by the technical aspect. It's just your processes. Like you said, Vlad, the change management meetings where everyone gets on a bridge and we all talk about the change. That's what's slowing you down. So that's really cool. Now, can you maybe, so obviously we see a new service on here. I'm not sure if folks are familiar with Lambda. A joke, obviously. We all know and love Lambda. But I see you've added that to the graph this year. Can you maybe just talk through, and going back to Nathan's earlier question, how did you decide, here's the services I'm going to use, and kind of here's how we're going to go about putting this on the graph?
So, funny story, I actually used Lambdas before I used containers. Not for these tests in my own development life. I added Lambda because people asked about it. I didn't initially see the point in the previous 2 years because, unlike for containers, Lambda publishes its performance metrics. So AWS has a page on the Lambda docs that discuss in detail how Lambda scales. So this, a lot of people had trouble finding the line. It's on the extreme left, the purple line. So it spikes instantly to 3,000 instances. And then every minute after, Lambda adds 500 new instances. It depends on bigger and smaller regions, but that's about it. And this is documented by AWS. I didn't think to include it in the previous tests because there wasn't going to be a surprise. If AWS tells you, hey, it's this fast, like it was going to be this fast. And I knew from my own work and the applications I was running on Lambda that, yeah, it does indeed follow those performance metrics. Also, Lambda is a bit different. Lambda is not containers. I know you'll launch Lambda containers, but that's not Lambda containers. That's Lambda tar.gz in addition to the Lambda, which is just lambda.zips. It's a different way of packaging it. I don't necessarily think of it as containers. So, and I do go in some detail in the blog post about this. You cannot actually compare Lambda with containers. For some workloads, is kind of comparable. Like if you have a bunch of messages in an SQS queue and processing them takes, I don't know, 4 CPUs and 2 gigs of RAM, and you want to max that out, yeah, Lambda and ECS on Fargate are gonna be somewhat similar if like you close an eye and you accept all the differences. If you're doing something like HTTP requests, it's a big difference. Lambda only does 1 HTTP request per instance. That's not great because we have containers that can serve multiple requests at the same time. This depends wildly on the application, but containers can serve many hundreds of requests at the same time. Yeah, it depends. And that's something I try to avoid. Like, if you do this, and if you do this, and if you do this, you get these metrics. And what I actually try to do is, okay, I'm going to take the most default workload possible, which is a Hello World application. The code is public if you want to see it. I'm going to shove it into all of these services. I'm going to force scaling from 0 or 1 container to 3,500 containers, and I'm going to record the time. And that's it. I'm not going to get into any complexities. What complexities am I talking about? So things like image caching, like if your service is a tiny Golang application and you have, I don't know, 1 megabyte image, that's going to take way less time to download than, I don't know, a 6 gig Windows container that is running a big .NET application. How do you compare that? You cannot really. And that's one example. I do that in my work, like, hey, we're using EKS on EC2 with custom AMIs that pre-cache really big layers, and we have a big, complicated, fancy pipeline. But then the blog post wouldn't have been 45 minutes. It would have been like, I don't know, a couple hours, like, hey, read this blog, it's 8 hours long. And it's published in like 2025, because it took me so long to write it. No, I try to present the defaults. Like, all the results in here can be improved. It's up to you how much time and effort you want to spend to improve this, but at least we have a frame of reference. So we know, okay, Lambda is going to scale this fast. ECS on Fargate is going to be about this fast. EKS on EC2 is going to be about this fast. ECS on EC2 is going to do this. App Runner, which is not in this graph, but it's in the blog post, is going to be this fast. At least we have a starting point. We have a base that we can then optimize depending on whatever the application needs.
Yeah, and
And at least having those numbers, if I do understand the caveats and differences, I have a baseline to kind of understand what's going on there. But I think that's really interesting that you highlighted the difference between like Lambda and the other services where a particular Lambda function instance is working on only one transaction at a time in a series versus a container can actually be working on many concurrent things at a time. So if I have one container, if it's a light HTTP workload, I could be adding the capacity for 100 requests per second. Versus Lambda would be doing things in series, one request after another. So it's a completely different amount of capacity that's being added. And I think one of the things that really interests me, fascinates me about containers is that, especially with Fargate, you can adjust the container size up and down. And we're at a point where you can add a ton of CPUs and memory, very quickly, like within a minute. And, hundreds and hundreds of CPUs, hundreds of gigabytes of memory, per second. And that's amazing, like to be able to ramp up that capacity and be able to add so much more capacity for serving requests or whatever you're doing.
To be totally fair, Lambda gets more CPUs. Like Lambda can get at most 10 CPU. Was it CPUs or was it CPUs? So Lambda can get 6 vCPUs, so 6 cores. Fargate can go as high as 4.
Yeah.
Also, like I tried figuring out the best way. So this all started in November. Please note that we're in April. So this took forever. And I started this actually by talking to a bunch of people. I literally set meetings with friends, with customers, with people in my network and asked them, hey, how would you like this to be tested? Because initially I actually wanted to test, let's put the Hello World app both in App Runner, Lambda, and ECS on Fargate and spam it with requests and trigger it to scale. And that sounded awesome. But then, how long should the request take? Because I'm just returning hello world. That's not really relevant. Like, I should maybe do some work. Okay, how long should that work take? What should it do? How much CPU? How much memory? Should I compute pi? Like, what should I do? And it got really, really, really complex. And they cannot easily be compared in a general way. Like, I don't know, hire me. We can have a workshop, we can discuss your own workload, we can compare it, but that's gonna take us at least a day, and it's going to be very in-depth. That would not bring any value to the general population, which is what I tried to do in this blog post.
Yeah, and so to avoid us going down the rabbit hole of doing just that, comparing the different options, I think this is a great visualization. Lambda is amazing. The scale Lambda runs at, the speed is incredible. And also, when you run containers, ECS and EKS, we can see the speed has improved over the past couple of years to meet the performance needs of customers. And let's maybe talk about. So I guess we went through the graph here. I think this is a great representation, high level of kind of what you tested. Is there anything that maybe, we want to talk through the quick TLDR and then maybe jump into, we can start with EKS and go from there?
I want to address Newbie's question about 3,500 being a limit, because it's not. That was just what Vlad was testing at. In the blog post later on, there's a very, very tall graph of different limits that you can see. So if you go read the whole thing, you'll get more details. It's just how they scale at the really large, sizes tends to be more of a step as you get larger and larger. So if you're going up to, did you do was it 60,000 or 100,000?
50,000 for Lambda and 10,000 for ECS on Fargate. I chose 3,500 because I needed a number that was big enough but not too big. Like, I could have tested to hundreds of thousands of containers. Nothing would have stopped me. But that would have been unnecessarily wasteful, both in terms of destroying the planet, in terms of my AWS bill, and not really relevant. But I also couldn't just scale to 100 containers. That would have been tiny. Not really helpful. And 3,500 seemed like a good enough number. But no, it's not at all a limit.
And
the default soft limit is 1,000 Fargate tasks, and I believe it's also 1,000 concurrent executions in Lambda. but soft limit, so not hard limit. You can get that raised. You just have to open a support ticket, and support engineer will then raise that so you can launch more things in parallel.
And it's not like getting your limits raised. Is not a complex thing. It's more of a safety thing. Like, hey, I accidentally launched, I don't know, 5 instances in my account because I have an instance of 5 limits. It's much better than, oh, oops, I had a script and this loop went a bit weird. I forgot to stop it and I launched 5 million EC2 instances and now my bill is huge. Please help me. Like, those limits aren't there necessarily to restrict you. They're also there to help.
And the thing is, it's not even the limits these days. It's not even just for your own script. It's also to protect you in case your credentials get leaked. There's a lot of people out there who, if they get your credentials, they'll immediately spin up a ton of crypto miners to try to make a quick buck off your AWS bill. And so we have limits in there largely to help protect against that sort of abuse as well.
And you know, that it's a good point. I think I jumped ahead a little earlier, but talking about these limits, you know, Vlad, you really, the one thing I appreciate is that you went through this with the lens of, I'm not the top 1% here customer who's got all sorts of crazy things and I need massive scale. You took the lens of the everyday customer, the everyday user. So, you know, and you had one thing in your blog that I really love is it's not performance quota increases. These were just capacity quota increases, right? So I guess, what was the lens? I mean, you kind of went through that. So let's talk about the approach you took for testing and how you approach setting everything up and, you know, auto scaling versus not. You go really deep into that into the blog. You want to maybe talk a little bit about that?
Yep, sure. If you're really curious, the Terraform code I used for this, I had to use some infrastructure as code. I would have loved to use CDK, but nah. I had a lot of Terraform code already, so I just copy-pasted it until it worked. It's on GitHub. It's public. You can look at exactly what code I used to configure all this and all the options and all the everything. But don't take inspiration from there. Like, it's really, really horrible code. It's not prettily organized. It's not following best practices. It has some like really secure IAM policies for no reason, but then some really wide open security groups. It's code that worked. It's not code that's pretty.
It doesn't work with the newer versions of Terraform because I did try to deploy it yesterday and I have a newer version. So this is from November. Terraform has probably had 2 releases since then. So anyone that wants to do it, you have to update some things.
The version is specified in there, the version that I use.
Yeah.
But yeah, so I went again with defaults. I tried to keep stuff as default-ish as I could. So that's basically the out-of-the-box experience. Let's take Kubernetes as an example. So I do a lot of work on Kubernetes, like lots of work. I absolutely know every single piece, or that I'm exaggerating, I'm not that smart. I know most pieces of Kubernetes that you have to tune to get the best performance. For example, you can tune the networking in Kubernetes to start up faster. There are some environment variables. They are well documented. You can tune them. If you're using Cluster Autoscaler has a bunch of options that you can tune to make it scale faster for your workload. But we're yet again getting not only into you really need to know everything to scale, but we're also getting into specific workloads. So how often would you like Cluster Autoscaler to look at what's happening in your cluster and then scale your cluster up? For some folks, like we desperately need it to be 2 seconds. Because we know it's gonna finish, we over-provisioned it, we gave it a bunch of things, we raised the API limits and all of that. For other folks, like 30 seconds is fine, and I mean we're running at super high scale, so it's not Cluster Autoscaler cannot even finish looking at stuff that fast. There's a lot of complexity that can be in there, so yet again, I chose the defaultest option, which also means these are again default performance levels. So that's how I set this up, and it's discussed in detail. This all happened in a dedicated AWS account, everything that I did, and the reasoning is here. I also, again, we are forcefully scaling from 0 or 1 container to 3,500 containers. I didn't get into and that's exactly what's on the screen right now. I didn't get into the whole setup of the whole scaling pipeline. So when you actually scale in the real world, it doesn't always look like this. Like, yes, some people forcibly scale, but there's only a few of them. First, you need to you need to collect some metrics, like how many requests are coming in, for example. You need to collect them, you need to look at them, you need to make a decision, you need to figure out what number that is. Like, okay, we saw that we got an increase in request, to how much should we scale? You have to make that decision, you have to do the API call and all that. Like, you can do all this with a bunch of different products. So you can do it with CloudWatch and AWS Autoscaling. You can do it with Prometheus and the horizontal pod autoscaler in Kubernetes. You can do it with Keda. You can do it with a bunch of different things. And again, I didn't want to get into all this complexity. So I just went, nope, just gonna edit the number of desired containers and we're gonna scale to that. For Lambda, yeah, go ahead.
I was just saying that answers the question here that DevOps Directive had about time it takes to actually create the containers or the pods inside the cluster versus creating nodes that can run those containers and pods. And in your case, you started from one, which had one instance type. You mentioned it in the article. It's a 6, I forget which one it was. Whatever, you started one instance and you let the autoscalers of all of those systems add nodes, which was essentially the time that it takes. Because if I already had the existing compute to do all of this, and I just said, go run my container, it would have been a lot faster. Because then it's just a matter of like containers create, pull, images, run. And all of the compute already exists. But in this case, you wanted to see how do I add and remove that compute capacity. And that's exactly what Fargate's doing on a one-to-one, task per node sort of basis. And so, yeah, you're scaling up the cluster to reduce cost because that's where most of the spend is in that compute. So if you have a cluster, and even we have an old video of Carpenter where I did 10,000 pods with Carpenter, and I told it just like, hey, just give me the largest instance, and I just had it there, and Carpenter just sticks it out there, and the whole thing ran pretty quick. But that's sort of a different scenario than what you were testing of. I want clusters to scale up with their compute needs up and down as needed based on container demand, not sort of a static definement of, here's the thing that exists, now just run things on it.
Yeah, and it's another layer of complexity. So let's take the scheduler, for example. In Kubernetes, the scheduler works based on namespace segmentation. So you can tune that by using multiple namespace. That could become a limit, and so on and so forth. I didn't want to get into that. I tried to get it as default as possible because there are a lot of optimizations you can do. And we're talking about Kubernetes here because Kubernetes has the most knobs, but the same things apply to ECS on EC2, to ECS on Fargate, and even to Lambda.
And at some point, right, when you're doing a test like this, you have to stop, or else it wouldn't have been April that you finished. It would have been November 2025 when you finished. You know what I mean? Like, it's just, there's so much. You have to make these decisions and just own them and call it out in the blog, which you did. Like, I love that you used an image size that represents probably realistically most of how the folks are building container images. It's 380 megabytes. Yes, there are people that optimize their images super lean, super, tight, but you kind of took it as like, here's how maybe most people are deploying, and we're taking an average here. So you can optimize everywhere, but this really just speaks to a more general story, which is fantastic.
Yep.
Okay, so now I think, because I know we could talk all day on this. I want to just get into the nuts and bolts here. So let's talk about Kubernetes.
Roll until the first picture.
All right, let's get to the first picture.
So if you don't have the time to read the blog post, just look at the pretty pictures. That's it.
They are pretty.
Yeah. So what we're looking at here is EKS on EC2, the yearly evolution. Again, the graph on this is 60 minutes, and there are actually 3 lines in that graph. If you really zoom in, Adam, please don't zoom in. You can see that they very much overlap. Like, there isn't much to optimize. It's basically launching a bunch of instances. It doesn't really help. And I could have stopped here with the testing, but I thought we should get into some more details. So if you can scroll to the next pretty picture, So in 2021, we got a different option for scaling the cluster, and I go into what that is and what happens and what they do. But basically, there's a piece of software that's running on your Kubernetes cluster that's looking at, okay, how many containers do we have in here? Can they all run? Yes? Awesome. No? Let's add servers. That's what it does. And before, when was Carpenter released? I think 2021. In 2021, an alternative came out, which is Carpenter. Before 2021, most people use Cluster Autoscaler, which is super popular, the default in Kubernetes. It's a big community project. And it's fine, but as I discussed, it's opinionated and it's not fully integrated with AWS. Cluster Autoscaler has to work on all clouds. So it has to work on AWS, it has to work on Google, it has to work on Microsoft Azure, it has to work on DigitalOcean, it has to work on Linode, it has to work on Hetzner Cloud, it has to work on VMware Cloud. And that, just like Kubernetes, means working at the absolute base layer of the lowest common denominator, which doesn't allow you to do a lot of fancy optimization because you know what you're working with. AWS was like, yeah, this is not ideal and our customers want more. So you all built Carpenter, which is an alternative. It's open source. Right now it has support just for AWS, but folks can add support for other things. Again, it's open source. And it is indeed a bit faster. I'm going into details in the blog post. What we are actually seeing here is the absolute worst case for Carpenter scaling and the absolute best case for Cluster Autoscaler. And even in this horrible scenario, Carpenter is faster, which is just a testament to how awesome Carpenter is. Beware, again, I work a lot with these tools. Carpenter-only clusters are quite rare. Like, Carpenter is scaling up super fast, but it's not yet ready for all workloads. For example, a thing that got mentioned a lot is defragmentation and bin packing. There's an issue on the Carpenter roadmap, which again, open source, it's open, you can look at it. So Carpenter doesn't yet have that. You have to look at it for your workflow. But, and this is the important part, you can run both of them. If you have a thing that Carpenter is really, really good for, like scaling super fast, you can use Carpenter only for that particular deployment and Cluster Autoscaler for everything else. So you're not restrained. You can use both of them at the same time. And that's like really, really short Kubernetes story. Do you have any questions or can we go to the next graph?
Justin, you're muted, but is there anything you want to touch on with the Carpenter stuff? Because Justin's put out like the most amazing videos on Carpenter. ContainersFromTheCouch.com, you can see all those great videos.
So yeah, we have Carpenter videos. We've actually been doing Carpenter videos for years. Carpenter actually originally was launched in 2020, but was kind of officially reInvent launched in 2021. So we've had content for a little while, which is amazing that it's been maturing. And we have from at least the reInvent launch sort of stuff, we want Carpenter to be extended for these other environments. And we want it to be the best scaler for any Kubernetes cluster. So we have those extensions in place to work in other areas. But yeah, we've optimized it for AWS workloads because that's where we have our expertise. And that's exactly what you mentioned. Cluster Autoscaler is looking at that, what exists in pretty much every environment has some way to group nodes and then add one to that node group. Carpenter kind of brings that scaling into more of a Kubernetes native approach where Kubernetes knows about nodes, but it doesn't know about groups of nodes necessarily. And so we're just saying, well, let's just give it the best node for those workloads. And I always like to call it the workload native scheduler. And so if you have something that needs these special workloads, we'll get you the right instance type for that. So yeah, that's why we think that we want it to be the fastest scaler, and we do a lot of optimizations in there to make sure that pods get assigned to nodes as quickly as possible, which is where you're seeing some of this. In the previous examples of the videos we have, just as mentioned, we had different cluster settings that did fine tune these things to, hey, let's scale this faster. And so like a COPS cluster with higher scaling limits on the API server, we were able to get to 10,000 pods in under 10 minutes. And so we could scale really quick if we want to. But again, it's all trade-offs. And if your workload doesn't need that, then figure out what the best settings are for your workloads based on availability, on spread, AZ, everything else. You need to take into consideration what you need.
My favorite thing about Carpenter is the fact that there is a strategy where you can say lowest price. And so it analyzes the EC2 instances that are available and says, based on the size of these pods and how many I can fit per container, there's going to be a certain EC2 instance where it's actually cheaper per CPU potentially to run the workload on this instance type than on this other instance type, looking at the full number of EC2 instances you'd have to launch. And so it's aware of these things. So not only does it try to be fast, but also tries to be efficient with your time as well as your money.
Super powerful. All right, so let's move on to the next one. Vlad, we got about 15 minutes here, so I want to make sure we give love to all of our friends across all services. But anyways, let's keep going.
Yeah, so what we're looking at right now on the screen is IPv4 versus IPv6. So IPv6 became much more mature in AWS in the last months. Kubernetes also got support, so I tested that. And IPv6 is indeed, as you can see here, just a tiny bit faster than IPv4. There's less networking thing that has to happen, no more ENI complications and things like that. Again, with default settings, so you can optimize both of them. But if you're launching a Kubernetes cluster today and you want it to scale as fast as possible, I definitely look at IPv6 as a real option. It matured a lot and support is super stable. And that's it for Kubernetes. I had to decide. Oh, and Fargate. Sorry. Fargate. Yeah. That was it for Kubernetes, for EKS on EC2. So for Kubernetes with EC2 workers. But there's also Kubernetes with serverless workers, which are Fargate. And what we see here in the graph is how much Fargate has evolved. And we've talked about this. Like it went from about an hour to what is it now? Less than 8 minutes? That is a dramatic improvement that, again, came with absolutely zero effort. It's awesome. A lot of people are going to complain EKS on Fargate doesn't support things like daemon sets. It doesn't support spot, which is basically price reduced by up to 70%. Yes, those are indeed current limitations, but a lot of applications don't need daemon sets. You can do sidecars, for example. There are workarounds. And the speed is awesome. And for the first time, Fargate is faster than EC2 workers, even beyond that initial period of time.
That's amazing.
It really is. Let's go to ECS.
Yeah, okay. And this is just that last graph with everything, right? For Kubernetes, for EKS.
All the lines, all the mess, so you can compare them. And I also added EKS with all the EC2 servers already there, just, for context. Okay, let's go to the next graph, which is going to be ECS on EC2, which, shout out, I figured it out with Adam's help. So ECS works a bit differently. Think of services as deployments in Kubernetes, but in ECS, if you increase the number of services, you get more performance. There's a difference in how the scheduler works. I discussed all of this in the blog post. But the first thing we had to do was figure out what's the ideal number of services for ECS on EC2 and our application and our workload. That was 5 services. So that's what I did here. And if you scroll down to the next one, next pretty graph, we're discussing different options. So for ECS, you can set target capacity as a percentage. That means, hey, I want my cluster to be this utilized. I want my cluster to be 95% utilized. Means only keep 5% extra space in there for containers that might be needed to scale up faster. So you're only keeping like 5% free. You can also go at the other extreme and keep 70% of your cluster free by setting up 30% target capacity. I wouldn't do that. That just means throwing 70% of your money out the window. Not necessarily out the window, but keeping it ready for other workloads, which, not ideal. But we're seeing that ECS on EC2 does scale in an awesome way, and it is way easier to use than Kubernetes.
And this is using the ECS cluster autoscaler, right? Which is through ECS capacity providers.
Yes.
So
And this graph shows, like, if you keep more free space in your cluster, the workloads will run faster because you have less instances to create each time you want to have more. So that 30% line, if you actually need to scale up, you could have the spare capacity just sitting around and it'll scale faster. But if you want to utilize more of it and you want to spend less money for your total compute, then you need to go to, your scaling up might be a little bit slower as we add, more instances.
There's still a lot of improvements we can make here, though. I'm hopeful that in another 1-2 years we'll be able to have a 95% target capacity, which also looks that fast. So definitely an area where, looking at this, I can see what needs to be done in terms of improving the performance, so you don't have to have 30% target capacity.
Yep.
yeah.
Let's
Absolutely.
move on to serverless ECS. So ECS on Fargate. I really do think that ECS on Fargate is what most people should be using. So first up, it's massively different from EKS on Fargate. There are more options. What we did here was yet again figure out the ideal number of services. It was yet again 5. 7 services was just a tiny bit faster, but didn't really help. But again, ECS on Fargate has a lot more options. Adam, let's go to the next graph,
Right.
which is, it's the yearly evolution. So we can see ECS on Fargate also went from about an hour to less than 5 minutes. That's dramatic, and it's even faster than EKS on Fargate, if you want to compare them. But it's, again, a dramatic improvement. I had clients who I moved to ECS on Fargate in 2020. I told them, yeah, trust me, do it. And they were able to move so much faster by focusing on their application, and they made so much more money. Let's go to the next graph. I'm not gonna sing my praises. Yeah, we also have ECS on Fargate Spot, which is about 70% cheaper. That's a really big deal, especially if you are using a lot of compute. I tested it. It's here a bit faster. It was also a bit slower. It was also just as fast. It depends a lot on capacity. And pro tip, for ECS on Fargate Spot, performance will also vary quite a lot between different containers. Be aware of that. They're 70% cheaper though, so launch a bunch.
Vlad, there is something else you mentioned in the blog that caught my eye, and I just thought it was super cool to talk about. Is not only did over the past 2 years have we seen Fargate improvement across ECS and EKS, right? So speed improvements, launch time improvements, but with ECS on Fargate, costs went down. So you actually got performance improvements and you paid less over the past 2 years. That's really incredible. And it just speaks to the engineering efforts to get customers better performance, but also really the customer obsession and really focusing on doing what's best for the customers and trying to give them the best cost possible. So just really cool. You pointed out in the blog. I had to call that out.
No, it's a huge deal. Fargate launched, and in my view, it was a preview service. It was slow, it was really expensive, and it was really limited. It was a preview. It wasn't great. But there were 3 price cuts. It evolved massively. It got so much faster. It got Fargate Spot. You really need to keep up to date if you're running into the cloud. Because again, AWS has those many hundreds of engineers whose only purpose in life is to make AWS services better. That's a big deal.
Absolutely. Do you want? Let's continue on. Oh boy, this is a big one. I can't even fit this on the page.
Yeah, so as you can see there, Fargate kind of tapers down when getting really close to 3,500 containers. And I was like, is that a limit or something? So I went to 10,000, and yeah, no, it's not a limit. It's just when you have 2 containers left to launch, that's gonna take a tiny while. It's not gonna scale as fast.
That's the P99, right? I mean, that's just that last percentage of. Yep.
Yeah.
So it takes about 10 minutes for ECS on Fargate to go to 10,000 containers. Really easy math. Let's go to the next graph, which is actually more exciting.
So really quick, I do want to call out, before we get here, and maybe we'll come back to it, but Nathan did write a really awesome blog that talks about, with ECS, the task launch rates and some of the things that we've improved on the back end, and that he really dives into it here. So I want to just make sure we give a shout out to this blog. for folks to read through
Yes.
to really understand this.
It's awesome. And again, I had to make some decisions. I couldn't test a bunch of things. Nathan was awesome, and he tested, like, what happens if you're running ECS on Fargate in public subnets? What if you're connecting them to an ALB? That's really awesome data, and what about AWS Batch? That's also in here. Definitely read this. It's awesome.
Yeah, so the biggest thing in here is that I wanted to share from that blog post is that we made Fargate around 16 times faster, and scheduling ECS and EC2 doubled in speed. So that's the reason why you're seeing these improvements in the graphs from like 2020, 2021, 2022 is we've put a lot of work over the last couple of years in making things faster and faster. And that's across a couple different dimensions. One of the bottlenecks that we improved for everyone was just the ability to launch more Fargate tasks faster. That was sort of an underlying thing where Fargate was only allowing you to launch tasks at a specific rate. And so what was happening is if you had a very large account with multiple services and all those services are trying to deploy Fargate capacity, well, Fargate was saying we'll only give you tasks at a certain rate. So we've made that rate 16 times faster. The other thing that we've done is inside of ECS itself, when you're launching a really large workload like those 3,500 containers, ECS doesn't go and launch 3,500 containers all at once because that would just absolutely destroy your hardware, destroy your network. There would be quite a mess that would happen there. But instead, what it does is it goes through and executes these workflow cycles, as we call it, to execute a batch of containers. So we've increased the size, we've optimized that so that way it goes through fewer workflow cycles faster in order to get you from 0 tasks to 3,500 tasks much faster. And so between those two things, you're seeing like dramatic improvement in those graphs.
Awesome. Yeah, thank you. So definitely check out that blog. We posted it in chat to get more details. So we got about 5 more minutes. Let's zoom through this. It's so much to talk through.
Yes. So what we're seeing here is ECS on Fargate ARM. AWS built their own processors because AWS is not just somebody else's computer. It's somebody else's computer sitting in a building using custom concrete, running on custom processors and custom hardware. It's not just somebody else's computer. And what we're seeing here is that it's a tiny bit faster. Definitely use it. It's awesome. Let's go to the next one.
Yes.
Again, a bunch of details are discussed in there. If you got a question, you can also spam me on Twitter. So this is a big deal. A lot of people would dismiss it, but ECS on Fargate also has support for Windows containers. And I know a bunch of you will laugh like, haha, Windows. No, there are a lot of companies that are running .NET applications that cannot easily be moved to Linux through the new .NET support for Linux, or that companies that just don't want to invest that effort right now. And ECS on Fargate got support for Windows, and it is ridiculously fast. It's just as fast as Fargate for Linux, but we can see here that it actually starts scaling around the 5-ish minute mark. That's because Windows images are actually quite larger. The Windows image is about 2.5 gigs. And I actually had some really fun experience with that. I'm linking here also to a Honeycomb blog post. If I wasn't using proper observability through Honeycomb, this graph would have been much worse. Observability, it's important. Go read that blog, but we're gonna move on to the next graph.
It's super.
I'm actually really curious what would happen if you launched larger Fargate tasks there, because decompressing a multi-gigabyte image takes a long time. And I wonder.
I tested that. Images, there wasn't a big difference.
Interesting.
Actually tested it after we discussed it. But again, AWS move fast. Definitely test it for your workload. So let's keep through this one. This is all ECS.
App Runner.
And App Runner. Yes, we have to talk about this. So this graph is different. App Runner only supports running up to 25 containers right now. Like, do you want 26 containers? No, can do right now. Sorry. You can have multiple services, but one single service can only support 25 containers. And a lot of people would laugh like, ha ha ha, 25 containers compared to 3,500. Well, yeah, no. This is still like 100 gigs of RAM. How many applications do you have that actually need more than 10 gigs of RAM? It's large enough for a lot of applications out there, especially for web services. And it is so much more integrated, so much easier to use. It's scaling to almost zero. It's optimizing cost. You don't have to stress. Like if you're using ECS on Fargate, you still have to stress with AWS auto scaling and CloudWatch metrics and setting that up. It's a hassle. AppRunner just works. It's awesome. It's a new service. It's not an ideal fit for everything, as we can see here, but remember those customers that I started moving to ECS on Fargate in 2020 because I saw the potential? Some of those customers are moving to AppRunner. I genuinely think AppRunner will be the default way of running containers, maybe next year when it evolves, but I'm definitely keeping an eye on this. Next graph.
Love that.
Oh, next
Love
graph
that.
is Lambda. Which,
last but
again,
not least.
yes, this is, you're gonna have to zoom out, I'm sorry. I don't even know, so I'm in the process of redesigning my blog post, which is why the homepage is a potato. I'm sorry. It worked, not great, but it did. So again, Lambda containers, or Lambda itself, cannot be compared with ECS on Fargate, but I had to do it. People were asking about it, we had to get these graphs, and this is what happens. Up until the 7th minute, Lambda by default is faster than ECS on Fargate, and then ECS on Fargate takes the lead. It just keeps going like this. And the steps you see there, those are the steps when a new minute actually starts, because that's when Lambda adds those 500 instances. But we have one more graph, which is
There's
a
two
really,
more.
really...
You gotta go to the second one because this one.
Yeah,
is
the
like
second
3
one.
minutes. But then the next one, you gotta
This
just
one's
keep
just-
scrolling.
Yeah.
Okay,
Scroll.
here we go.
Like, this is a ridiculous graph. As it turns out, AWS actually cares about their customers, and AWS wants to brag about how much faster AWS is. So if you have a workload that is really, really intense and needs to scale a lot, a legitimate workload, not like, hey, AWS, I just want to do this for the, I don't know, Twitter screenshot. Yeah, no. But if you have a workload where you need to scale up a lot, maybe you're a SaaS company. I know a bunch of customers that are actually using this. You can get Lambda limits increases. And I got my Lambda increases to 15,000. So that's a burst of 15,000. That means that instantly Lambda will give me 15,000 containers. That's ridiculous. And if you scroll down a tiny bit, I actually did the math. That's how much is it? So yeah, with the default limits is 30 terabytes of memory and 1800 cores. With these increased limits, you can get 150 terabytes of memory instantly. Like, in less than a second. It was horrible trying to flood Lambda with that many requests in a single second. Like, I had to do that.
Did you feel bad doing it?
It was really wasteful, but it's such a force multiplier for amazing companies. Read this blog post.
Okay, so yeah, we have to wrap. Vlad, thank you so much for taking the time to do this. As you can see, folks in the comments are just like saying how awesome you are, and thanking you for all the effort you put into this. And Justin, Nathan, thanks for being here to help talk through a lot of this. Check out the blog, and if you have any questions, we're all on Twitter. You can reach out. We're glad to talk anytime. And Vlad, you're amazing. Thank you so much.
Thank you so
for
much,
writing
man.
that article.
Thank you for making such awesome services. Like, again, look at ECS on Fargate. Ask me questions on Twitter.
Awesome. Thanks, y'all. We'll see you later.